The ends of the earth. In the searing heat of Australia and the frozen wastes of Antarctica, life can be unbearable. The dinosaurs that ruled these lands were the toughest creatures that ever lived. How did they overcome the odds and survive life in the deep freeze? Australia, 100 million years ago. Adrift in the southern reaches, its jagged peaks are covered in snow. But in the lowlands, life is flourishing. On the banks of a primeval waterhole, a group of small dinosaurs gather peacefully to drink. Suddenly, the calm is broken. A new creature intrudes on the scene, bent on more than quenching its thirst. What happens next is chaos. In time, the water hole would vanish, but not the scene of the crime. Today, the site is sheltered to protect it from the harsh conditions of the Australian Outback. Called Lark Quarry, it's located near the town of Winton in central Queensland. Paleontologist Tony Thalborn believes this remote spot reveals the story of what happened in 10 seconds of time that tragic day. Preserved in rock, this is the largest dinosaur trackway on Earth. 3,300 footprints representing some 160 individuals were made in soft clay. They seem as fresh today as if the dinosaurs that left them passed this way only yesterday. For Thalborn, it's the footprints of one creature that tell the chilling tale.
What's interesting is that the first half of the trackway here shows long strides, the creature's walking along quite smartly. Halfway along, he suddenly slows down, the footprints become shallower. The creature's obviously becoming a bit more hesitant, a bit more careful and cautious as it approaches the waterhole down there. It's as if the creature is stalking something.
What it was stalking was two types of dinosaur. Tony has been able to identify them from the shape of their footprints. The first are from a small herd of plant eaters called Wintonopus.
It's a rather chubby foot, square at the back, 3 divergent toes, and it's basically herbivorous, if you like. It's a sort of dinosaurian sheep.
These narrow claw feet imprints belong to meat-eating dinosaurs christened Scartopus.
That's a predator, a scavenger, an insectivore, an opportunist, feeding on insects, eggs, plants, carrion, anything it could get its little hands and jaws around and swallow.
The two species drank side by side, unaware of the danger that lurked nearby. Then, a large meat-eating predator appears out of nowhere. The trackway reveals what happened next.
At least 160 small dinosaurs ran in the opposite direction over the tracks of that big predator. They're all running together, same direction, same time, over that predator's tracks. It looks very much as if that's an escape route, an emergency way out, and they are taking it.
But there was no way out for the small dinosaurs. Their only hope was to charge the carnivore, running straight into the gaping jaws of death. How many died that fateful day is unknown. But the footprints are dramatic proof that prehistoric monsters once lived and died in Australia's desolate outback. Dinosaurs Down Under comes as a big surprise. Over the past 100 years, only a handful of fossils have been discovered here, suggesting the land was too harsh and uninviting, even for a giant reptile. But at the Museum of Tropical Queensland in Townsville are the bones of a creature that proves Australia was once a dinosaur playground. Discovered in 1926 near the town of Roma, this is the hind leg of Australia's oldest known dinosaur, Rhedosaurus brownii. 36 feet long and 20 feet tall, Rhedosaurus lived 170 million years ago. Weighing 20 tons or more, it was a member of the sauropod family, the long-necked, long-tailed plant eaters. Paleontologist John Long of Perth University thinks Rhedosaurus was one of the first sauropods that ever evolved.
Rhedosaurus is perhaps the first of the truly large sauropod dinosaurs to appear anywhere in the southern hemisphere. And we believe it's a primitive dinosaur, mainly from the structure of the foot here.
These are called metatarsal bones. They support the animal's huge body by spreading its weight down through its clawed toes.
And these metatarsal bones in Rhedosaurus are splayed out like the foot of a lizard, whereas in the really large, gigantic sauropod dinosaurs that were to evolve later, these bones are all bunched up tightly to form a column to support the huge weight of the animal, similar to the way that the structure of an elephant's foot is today.
Rhedosaurus roamed the outback of Australia during the famous geological time period known as the Jurassic. Back then, the world was a very different place. Most of the continents were cemented into two giant land masses. One was located north of the equator, the other south. The southern continent was called Gondwana. Situated at the bottom and still joined together were Australia and Antarctica. The climate during the Jurassic was cool. Plant eaters like Rhedosaurus foraged for food in the cool shade of a forest of conifers and ferns. But where there were plant eaters, the meat eaters weren't far behind. A killer like no other wrought terror at the ends of the earth. Today, the dense forests of Gondwana are long since gone. Buried under a field of perpetual ice and snow, the landscape is bleak and lifeless. This is the modern continent of Antarctica, one of the world's last remaining frontiers. The size of North America and Mexico combined, 98% of Antarctica is covered in ice over a mile thick. Its rugged terrain and inaccessibility makes exploration difficult, if not impossible.
Australia and Antarctica are two of the most difficult places to find dinosaurs, two of the places that have been most reluctant to yield ideas of what kinds of animals were living on them. But there are places where clearly dinosaurs existed.
In 1991, a band of tough fossil hunters from the USA mounted a polar dinosaur hunt to prove just that. Team leader Bill Hammer of Augustana College in Illinois fondly recalls the hardship.
The warmest temperatures we ever had in the middle of the Antarctic summer were 25 below 0 Fahrenheit, and sometimes it was 10 or 15 degrees colder than that. But you learn to deal with it. It's fun to live in a tent at 25 below 0. It's a challenge, let me put it that way.
The team was camped 400 miles from the South Pole and 14,000 feet high on Mount Kirkpatrick. Working in extreme cold at this altitude, the human body only receives about 50% of its normal oxygen supply, so breathing can be difficult. Undaunted, the team braved this challenging environment for 4 long weeks in their search for dinosaurs. Finally, they struck gold. In an area only 15 feet wide and 3 feet thick, they uncovered the remains of Antarctica's first dinosaur.
We collected about 120 or 30 individual bones out of this site. Nearly all of the bones go to the skeleton of one animal.
24 feet long, it was a killer with serrated teeth and sharp claws. Called Cryolophosaurus, it's the only 2-legged meat eater ever found in Antarctica. Its name means frozen crested reptile, after the curious bone protruding from the top of its head. Hammer and his team think the crest had a specific purpose.
It's very ornamented, and it kind of comes to a little peak on the top, and it was used probably for some kind of a mating display or something like that. It was species recognition. It was not an offensive weapon. It's not designed that way.
The crest of Cryolophosaurus is unique. No other meat-eating dinosaur has ever been found with such ornamentation, suggesting this bizarre creature from the south was evolving in its own peculiar way. But while it was marching to its own drum, the world around it was changing. Cracks appeared in the Earth's crust, and Gondwana began to break up. During the Jurassic, 150 million years ago, Australia and Antarctica broke away from South America and Africa. Now one gigantic island, they slowly drifted further away from the equator towards the South Pole. For every 1 degree south they moved, temperatures fell by 2 or 3 degrees. And the further they headed into isolation, the weirder they would become.
If you want to evolve, if you want to get a continent to sprout lots of different kinds of animals, including dinosaurs, you need isolation. If you want a new species of Triceratops, of Brontosaurus, of hummingbird, you've got to take a small population, isolate it from its close kin, give it enough time to evolve its own adaptive signature, and then release it. Without isolation, you won't get new species.
For dinosaurs stranded in Antarctica and Australia, life would never be the same again. In the blistering cold of the polar regions, evolution was heating up. The dinosaurs of Australia and Antarctica were cast adrift. Now their island home was moving further and further south. As the cold started to bite, plants stopped growing and food became scarce. In the winter months, dinosaurs had to survive freezing temperatures and frequent snow showers. But theirs was not the only world undergoing change. The Earth was entering a new geological time period called the Cretaceous. 120 million years ago, the southern coast of Australia was firmly attached to Antarctica and only 700 miles away from the South Pole. Today, this same coastline is 3,600 miles away. Close to the Australian city of Melbourne is the small seaside town of Inverloch. In the summer, families flock here to warm themselves on its sunny beaches. In winter, it's cold and frosty. But when the sun is shining, temperatures rarely fall below 65 degrees Fahrenheit. Today, it's shirt sleeves for fossil hunters from Monash University in Melbourne who are digging up the bones of dinosaurs that once lived here. Less than 100 yards from where the dinosaurs died, Tom Rich of the Museum of Victoria has uncovered evidence that during the Cretaceous, the climate was a far cry from what it is now.
What we have here is a situation unique in the world at the time dinosaurs lived. We have evidence in this outcrop of seasonally frozen ground. The whole profile would have been frozen during the winter.
In summer, the ground thawed out and the heavier clay soil oozed into the softer sand below. Eventually, the clay couldn't sink any further and flattened out. Beneath it, the ground was permanently frozen, a layer of rock commonly known as permafrost.
What does this mean for the dinosaurs? It means that this area was very, very cold, a very difficult place to survive.
During the Cretaceous, this coastline lay well within the Antarctic Circle, where summer days were 20 hours long and winter days extremely short. As winter closes in on the dinosaurs, the sun slips below the horizon. At the end of the Earth, darkness descends for 4 months. Without sunlight, their world becomes even colder.
What kind of dinosaurs could live in that cool, damp environment? We didn't know. Now we know what lived there. And the big surprise, the bizarre thing is, they're not bizarre.
850 miles north of Inverloch, in the hostile outback of Australia, proof has emerged that somehow dinosaurs did cope with the cold. In 1989, in Roma, central Queensland, scientists discovered Australia's most complete dinosaur to date. Almost all of its bones were recovered. It's so well preserved, even impressions of its skin are visible. This is Minmi, a medium-sized plant eater with a relatively large head and armor plating designed for protection from predators. The armor not only covered Minmi's back, but ran all the way under her belly. Armor-plated dinosaurs usually ranged in size from 15 to 30 feet. Minmi was only 9 feet long and had unusually long legs. Her long legs suggest she was active and could move fast. Her smaller size helped her conserve energy. By generating her own heat, Minmi was able to survive the cold. It's clear that Minmi's size was the key to its survival in these harsh conditions. Today, many creatures that live at the poles adapt to the cold by scaling down in size. The Arctic hare and fox are up to 20% smaller than their counterparts in warmer climates.
In general, the larger animals require larger amounts of food and travel longer distances to find it. So when there's less food, there's less room to move, scaling down makes every sense in the world.
Becoming smaller may be the most efficient way to combat the cold, but it's not the only one. The discovery of another dinosaur in the outback would shake up the theory of scaling down and ignite a primeval mystery. This is the Langdon homestead. Owner Doug Langdon has farmed this land for over 40 years. Cattle stations like this are scattered across 2 million square miles of plains, scrub, salt lakes, and worn-down mountain ranges, otherwise known as Australia's Outback. Langdon's 10,000 acres are located near the town of Muttaburra in the heart of central Queensland. Each day he crisscrosses the land, checking up on his livestock. One day in 1963 started out much like this, but would end like no other.
Yeah, well, it started off just like any other old day. Was heading down, mustering down on the river for some wandering cattle. I rode onto this rocky outcrop, and when after I rode past it, I looked down and I noticed something in the rock, something unusual.
At first he thought it was the bones of a dead cow, but on closer inspection, he reconsidered.
I could see what I reckon parts of the backbone of whatever animal it was. I didn't know what it was at the time, of course. But it was too uniform and big to be a bullock or something like that. So I put a couple of bits in my saddlebag and brought them home, and I sent them down to the museum to be identified.
The Queensland Museum in Brisbane announced that Doug had found not only a nearly complete dinosaur, but a totally new species.
To think that I'd found a dinosaur that was unique to Australia and unique to the world, and to think that they were going to call us after my old hometown of Muttaburra and after myself, Muttaburrasaurus langdoni. And that was a great honour and a great thrill.
Muttaburrasaurus was 32 feet long and 16 feet tall, the largest dinosaur ever found in Australia. A plant eater, it had a long dagger-like spike on its thumbs for defending itself against predators. Muttaburrasaurus walked on all fours but could rear up on its hind legs to forage in the trees. Teeth specially designed for shearing were set into its jaw. Its skull had a hollow chamber on top of its snout, suggesting the ability to communicate. This is how it may have sounded. 120 million years ago, a distant rumble breaks the early morning stillness. A slow-moving herd of Muttaburrasaurus is on the move in search of food. The hollow chamber amplifies their bellows, warning the herd of any impending danger. A grazer, Muttaburrasaurus was an eating machine. At 4.5 tons, it had to consume at least half a ton of food a day to survive. Feeding a herd of them in the dead of winter would take a miracle.
You still had 24 hours of darkness in the middle of winter. And that means the plants, which were all deciduous, drop their leaves or go into a dormancy stage. And that means there's not much food available for the plant-eating dinosaurs.
Little or no food, how Metabarosaurus survived at the bottom of the world remained an enigma. But a shock discovery 4,500 miles away may finally solve the mystery. This is Merimbio Base, Antarctica. Here, the average temperature is 30 degrees Fahrenheit, but can drop to -60 without warning. Winds can reach speeds of up to 70 miles an hour. This scientific survey station belongs to Argentina and is located 2,200 miles south of Buenos Aires, on Seymour Island in the Antarctic Peninsula. In 1998, the Argentinian Air Force brought a joint team of Argentinian and American dinosaur hunters to this remote part of the world. From Merimbio, they traveled 40 miles across iceberg-strewn waters to Vega Island, where they set up camp. With less ice than elsewhere in the Antarctic Peninsula, it's the most accessible part of the continent. But ice was non-existent here during the Cretaceous, 120 million years ago. Vega Island was covered in a forest of conifers, pines, and ferns. Deep carpets of shade-loving mosses and plants grew on the forest floor. But even in the middle of summer, the angle of the sun was so low, the struggle for light was intense. Trees leaned towards the sun's rays, like houseplants do on a windowsill. Dinosaurs once lived here. But now the polar forests are gone, submerged under a sea of frozen water. All semblance of Antarctica's prehistoric world vanished 3 million years ago, when the temperature dropped a paralyzing 10 degrees Fahrenheit and an ice cap 10,000 feet thick slowly engulfed the poles. Since then, several ice ages have come and gone, and glaciers advanced and retreated. But the ice never leaves Antarctica, except on the peninsula. As the last remnants of winter melt in the summer sun, the team on Vega Island sets out in search of ancient creatures from a world gone by.
The most intriguing thing about looking for dinosaurs in Antarctica is the fact that as long as you can put up with the climate, it's like almost like going to another planet. Every site we stop at is probably a new site that nobody's looked at before.
A 2-hour hike from base camp, the team uncovered the bones of a plesiosaur sticking out of the ground. It's not a dinosaur, but a close relative that lived in the sea during the early Cretaceous. A candidate for the Loch Ness Monster, it was a reptile that fed on fish. For Sergio Morenci of the Antarctic Institute of Argentina, the discovery is a clear sign they won't find any dinosaurs here.
The plesiosaur we just found here tell us that this place was the bottom of a warm sea.
Even here, warm seas had warm shores. Sergio now thinks he knows where to look for dinosaurs.
If we are going to look for dinosaurs, we have to go up there.
But time is against them. They've already been here for 3 weeks. Although the sun shines for 20 hours and days are long, the Antarctic summer only lasts for 2 months. Soon it'll be time for them to leave. With another good day in sight, the team heads out. Their spirits remain high. If there's a dinosaur here, they're determined to find it. The dig site is on prehistoric dry land away from the ancient sea. But looking for bones on Vega Island is still like looking for a needle in a haystack 5 miles square. Jim Martin of the South Dakota School of Mines has what could be the most exciting find of the expedition.
Today was our best day. The best day since we've been here in Antarctica. The best thing was this tooth. This is a tooth that Dan found today. And this tooth, I suspect to be the first hadrosaur from Antarctica. We'll have to get it back to the laboratory to be sure, but my gut feeling is real good.
Hadrosaurs, known as duckbills because of the shape of their snouts, were large plant-eating dinosaurs that ranged in length from 25 to 35 feet. Walking on 2 legs or on 4, they dominated the plains of North America throughout the Cretaceous. Like Muttaburrasaurus in Australia, hadrosaurs were grazers that moved about in vast herds. Though their bills looked like a duck's, the back of their jaws were lined with hundreds of teeth for grinding vegetation. But would a single tooth from Antarctica match a hadrosaurus from North America?
As we compared the tooth with other teeth from here in South Dakota, we were amazed. The morphology was nearly identical. I was very, very surprised. Something that far away to be this similar to something in North America truly surprised me. We put it in the lineup of hadrosaurs from here in South Dakota. You can't tell it apart.
Finding a hadrosaur tooth in Antarctica is very interesting because we always consider hadrosaurs as being northern hemisphere animals. Certainly our knowledge up to now, and especially in textbooks and scientific publications, suggests that hadrosaurs developed in the north, and it was only at the very end of the Cretaceous that they got into the south polar regions.
Hundreds of hadrosaur skeletons have been found from Montana to Alaska, suggesting these large plant eaters migrated thousands of miles. As the winter approached in primeval Antarctica and the dark closed in, this was the signal to the hadrosaurs that it was time to move on. For those living where Vega Island is today, the warmer pastures of South America were their only escape. In front of them lies a long journey and a very big hurdle. 120 million years ago, Antarctica and Australia were still an island continent. 300 miles of water separated them from South America. But for Jim Martin, an ocean is not always an obstacle.
Now, if it wasn't dry land, something you can walk on, it may well have been land that was close enough through island series or island arc scenario where the animals could actually swim or raft from one island to another to get down onto the South American continent.
Perhaps when tides were low and the water shallow, dinosaurs could walk between the continents. Or like elephants today, perhaps they could swim. Escaping the polar winter by migrating was only possible for large herd animals like the Antarctic hadrosaur. But if the plant eaters abandoned their summer pastures, what did the meat eaters do? Waiting at the ends of the earth was one more big surprise. The smell of winter in the air. A bloodthirsty carnivore is on the prowl. Most of the plant eaters have migrated north. This kill could be its last meal for some time. 120 million years later, at Inverloch in southeastern Australia, the team from Monash University is still in pursuit of a dinosaur from the Cretaceous. But here, the tide is their worst enemy. Each morning, sand and pools of water have to be cleared away before work can begin. At Inverloch, the fossil-bearing rock is spread out along the beach within the tidal zone. The team only has 6 hours a day to look for bones. Despite the inconvenience, dinosaurs have been found here. Paleontologist Leslie Kuhl has a fragment of a killer that surfaced in 1979.
This bone is one of the most exciting finds that we've made in the last 20 years. It's the ankle bone of an allosaurid dinosaur. Now, this is a dinosaur we never expected to find here.
Allosaurus was a nasty 4-ton meat eater famous for stalking North America. One ankle bone is the only evidence that this vicious predator also terrorized Australia. But its discovery is rewriting the story of this monstrous creature. Not only was it a long way from home, it was also a pygmy.
The evidence from southern Australia suggests that the dinosaurs there really didn't get that big. If they weren't capable of migrating north, that is towards the equator, then they had to stay in that region during the winter months and basically tough out the winter.
Allosaurus must have relished the cold polar climate. In North America, it disappeared at the end of the Jurassic over 140 million years ago. But here at Inverloch, the rocks are 120 million years old, proving that in Australia, Allosaurus lived on into the Cretaceous for another 20 million years.
How they managed to cheat death, whether it was the environment or the isolation of Australia at the time, we really don't know. What we do know is that they continued living here when they went extinct everywhere else in the world.
To understand why the dinosaurs of Australia and Antarctica were so successful, scientists look to their modern-day counterparts. Today, Australia is home to the world's most infamous reptile, the crocodile. For a century, paleontologists thought that dinosaurs, like these fearsome creatures, were cold-blooded. Because their bodies lack the internal mechanisms to produce energy, they rely on heat from the sun to warm them up.
It's early morning here in northern Queensland, and cold-blooded creatures like this crocodile take many hours to warm up in the sun before they begin their daily activities, become hunting, lurking predators. But 100 million years ago, here in Australia, temperatures were much more extreme. Creatures like this just wouldn't have had a chance.
For cold-blooded dinosaurs to be active all year round meant functioning at temperatures at or below the point of freezing. John Long of Perth University thinks there's only one possible explanation for how dinosaurs coped with the cold.
Warm-blooded creatures like these kangaroos are much better able to handle the variability of climate, the extremes of cold and hot. much better than the cold-blooded crocodiles. To me, it's really the only explanation for how dinosaurs could survive in the cold climates of Australia. They must have been warm-blooded.
Whether they were warm or cold-blooded is still being hotly debated. In the right environment, even cold-blooded creatures can be a force to be reckoned with. The dinosaurs down under had licked the freezing temperatures. Now they would conquer the cold, dark nights. Unlocking the secrets of the dinosaurs' world is never easy. But when the going gets really tough, it's time for drastic action. "200 miles west of Inverloch, in southeastern Australia, is a place known as Dinosaur Cove. In 1980, paleontologist Tom Rich of the Museum of Victoria began uncovering spectacular fossils after blasting a labyrinth of underground tunnels out of a cliff. Some 300 tons of rock were removed and 200 feet of tunnels excavated. Then a team of volunteers searched through the rock for the scattered remains of a lost world.
Each worker might only find 1 or 2 bits of bone a day, but between 15 to 30 people, you'd rack up 50, 60, 80 fragments every day. What do you think it is?
I'd say maybe a vertebra, maybe desolate, but a small one.
Small one, yeah.
The task is painfully slow.
Have you seen this thing, Mick?
Nearly 20 years later, some 5,000 individual bones, but only 2 partial skeletons have been recovered. Tom's wife, paleontologist Pat Rich of Monash University, has been studying some of the fossils rescued from Dinosaur Cove in 1991.
There are 2 bones here, one of a juvenile and the other of an adult. It's a thigh bone of an animal called Tamimus.
Named after her son, Tim, Tamimus lived here 120 million years ago. 11 feet long, it was fast and agile, reaching speeds of up to 40 miles an hour. Instead of teeth, this dinosaur had a bird-like beak and preyed on insects and small mammals. Tamimus belonged to a group of dinosaurs known as the ostrich mimics because their long, slender legs and long necks show an uncanny resemblance to an ostrich. But this creature isn't unique. Ostrich mimics have been found in North America.
What's really unusual about this group is that it's known from the Northern Hemisphere, many different kinds, but until this record, we had no confirmed report of it from the Southern Hemisphere. So we're very excited about it.
How did a warm-weather dinosaur adapt to the cold? By comparing Tamimus to its North American kin, Pat hoped she'd be able to see a difference.
We couldn't find any hint whatsoever of what might be the adaptation allowing Tamimus to survive in these polar latitudes.
As nothing was visible on the outside of the fossil, Pat decided to take a look on the inside. The structure of the bone might reveal a hidden clue. In a radical move, she sawed the specimen in half, then took a thin cross-section for examination under a microscope. The sample was shipped 4,000 miles away to South Africa for analysis. At the Museum of Cape Town, Anasuya Chansami has borrowed a technique from the study of tree rings to study bones, in this case a bear's.
What we have here is the leg bone of a polar bear, and one of the things one can do with a bone like this is look at how this animal actually grows. What you would do is make a section of the bone and make it so thin that you can actually see the structure of the bone under the microscope.
bone reflects changes in the polar bear's lifestyle from one season to the next.
You have a broad band where the animal grows fast, and then you have this narrow dark band where the animal grows slowly.
The lighter bands show growth is fast when food is plentiful. In contrast, the dark bands indicate low intake of nourishment and slow growth. For a polar bear, that means it's winter. Growth comes to a halt as it shuts down its body to hibernate. What Pat Rich and Anasuya wanted to know was whether the bone of Tamimus would show the same kind of pattern.
What we have here is a section of Tamimus. When we look at its bone structure, we see that Tamimus actually has a period of fast growth followed by a period of no growth. This indicates that Tamimus was unable to grow continually throughout the year, and that at various times, possibly during the winter times, it actually stopped growing.
Back in Australia, Pat Rich received Anasuya's results.
What she told us was that we had a dinosaur that shut down at one time of the year in its growth and started up again another time of the year. So we immediately thought, what does this mean with regard to the way this animal was coping with this severe environment near the poles? And the only answer that we could come up with was hibernation. It's the only dinosaur that I know where there's any evidence for hibernation at all.
The bleak polar winter was 4 months long. Perhaps Tamimus would find a hole and sleep until the dark became light and spring once again descended on the South Pole. But Tamimus wasn't the only creature that adjusted to the hardships at the end of the world.
Australia gives us a window into an unusual dinosaur lifestyle, being a big-eyed, nocturnal plant eater, not much bigger than a turkey, able to survive a severely cold and wet Australian winter.
In 1989, the most astonishing find of all was made at Dinosaur Cove. The team uncovered the fossils of a creature so unique, its discovery has shattered many preconceptions about dinosaurs in high latitudes. Tom named it Dinosaur, after his daughter Dina. Only 3 feet long, this small dinosaur had 5 fingers on each hand for grasping and ridges on its teeth for chewing tough vegetation. With 4 toes on its hind legs, it could run fast, its stiff tail acting like a balancing pole. Dinosaur lived at the same time as Tamimus. Tom and Pat Rich wondered if it was also a dinosaur that hibernated. Once again, they called on Anasuya for help.
The bone structure is very different from that of the polar bear.
Dinosaur's bones show none of the dark lines that indicate it stopped growing and hibernated.
This means that this dinosaur, even though it lived in the polar environments, it was able to grow at this rapid, sustained rate, irrespective of whether the environment was hot or cold.
In winter, when it's below freezing, humans have to maintain a constant body temperature to stay active.
Like these guys, the Dinosaur was quick, agile, and able to blend in with her surroundings, a dense forest. But what happened when night fell?
Winter at the pole is an endless night. The world of the dinosaurs was lit only by the occasional appearance of the southern lights and the pale moon. For a small plant eater, life should have come to a standstill, but it didn't. Close examination of Dinosaur's skull revealed something astonishing. Its optic lobes were enormous. The optic lobe is the region of the brain where messages sent from the eye are translated into a visual image. A brain amply dedicated to processing light solves a major problem. Dinosaur could see in the dark. Today, we need state-of-the-art technology. But 120 million years ago, Dinosaur was naturally equipped with night vision. With this secret weapon, she could survive the dark winter months by staying active and foraging for food. Dinosaur shows that the dinosaurs of Australia and Antarctica were far more cleverly adapted to their world than we ever dreamed.
There's much more to the story than just the first Jurassic dinosaur from Antarctica. They've really filled in a lot of missing pieces.
Some endured winter in the cold and dark. Others migrated thousands of miles, and a few kept extinction at bay for millions of years.
Antarctica and Australia are extremely important. In many ways, they're keystones.
Still, so little is known. For the hungry dinosaur hunter, these two inhospitable continents are the last great frontiers.
There are areas, large areas, that have not been searched. That's enough to know for me.
In the unexplored reaches of Antarctica and Australia, who knows what remarkable creatures still lurk there from a time when dinosaurs ruled the ends of the earth.